Here we have a paragraph-based question from JEE 2008 chemistry section, and it's a question on from organic chemistry, and we basically have to figure out what I, J, L, and K are. K is a reagent, so okay, we'll figure that out. Let's first start by drawing the structure of hex 3-enol. So enol means it's an aldehyde which on the third carbon has a triple bond. So first you draw an aldehyde, and then this is the first carbon, this is the second carbon, this is the third carbon, and on the third carbon you draw a triple bond, and it should have been a straight line. So let me just do that. That's 2, that's 3, that's 4, that's 5, that's 6, 5 and 6, that's it. And that's the substrate we're starting with. First you add in NaBH4, so we know that's a reducing agent. It will reduce this aldehyde into a primary alcohol, not a secondary one, sorry. It will reduce it into a primary alcohol, though there is no subsequent protonation of the product that will form. So if a hydride comes from the NaBH4 and it attacks this way, then you end up having a hydrogen attached here and an O minus. Now if an H3O plus a subsequent protonation is not present, you should not make it an alcohol. But since the second step is adding PBr3, which is a good brominating agent, it might as well be something that you should have considered already. So let's just make it an alcohol anyway. And once you do that, now as I just said, PBr3 is a brominating agent. So instead of OH, you substitute back in Br. So you get Br here. And that's what I is. And let's check whether there are any possible contenders. Yes, there is. This is the structure that matches with ours. Next is now on I you add in magnesium and ether, and this is the way how we make Grignard reagents. And when you make Grignard reagents, there is an oxidative insertion of magnesium. So instead of the bromine here, you now have MgBr. And now you react it with carbon dioxide. So you bring carbon dioxide molecule near this, and since these are very good nucleophiles, and we already know that they will tend to attack on carbon dioxide and give carboxylic acids, we might as well just do that. So this, let me just erase these hydrogens anyway. So there was a negative sign coming here since the MgBr plus leaves. That's how Grignard reagents work. And that's the subsequent attack. Let me draw the arrows a bit better. And now what you're left with is the following compound. You have this entire thing right here, and you have C double bond O, and then the O minus that comes from here. And the third step is to add acid in it, and the purpose of that will be to protonate this O minus and give you an OH, so you get a carboxylic acid at the end. So this is what J is. So we have to figure out the structures of J and K together. So let's just first confirm whether we have J in here. Looks like we do. Both A and D have the same structure, and that's what we have made here as well. However, we need to figure out what K is, and the purpose of K is to make this into an acyl chloride. So you basically are exchanging this OH for a Cl right here. And so if you're making an acyl chloride, I guess the best way you can say is just put in some SOCl2. That gives you SO2 and HCl. Both of those escape. This is an excellent chlorinating agent, and that happens to be that happens to be in option A. So this will be the correct option. Once you have made this acyl chloride, what you're doing is you're hydrogenating it, and you're hydrogenating it over palladium and barium sulfate, which is poisoned by quinoline. And we know that this hydrogenation converts an acyl chloride into an aldehyde, and it also converts triple bonds into cis alkenes. Remember the Birch reduction, which is using sodium metal and ammonia, that gives you a trans alkene. This will give you a cis alkene. So let me just redraw what that structure might look like. This is an aldehyde. This gives you a double bond. Sorry, I should have done that better. So this double bond, this, and Ne. So let's figure out whether that's there in the option. Yes, there is. This is what option C is, and that should be the right answer.